This is MAP4C, day 2. The lesson that we're doing is lesson 1.1 A, which is finding sines and angles using trig and other stuff. We'll see the 3-minute review has actually got little bits and pieces of 3 different things. Some review, some not. Let's get into it. The goal, as it says, is to review measurement conversions, Pythagorean Theorem, and SOHCAHTOA. So 3 different things, one for each question here. So in number 1, we're asked to convert from, this is imperial measurement, 3 feet. The 1 tick is feet, 3 feet and 6 inches, just into inches. So obviously 6 inches is okay, but we got to change the feet, and each foot, remember, is 12 inches. So then 3 feet is multiplied by 3, 36 inches, and then plus the 6 that we started with, 42. Metric conversions, 8.25 kilometers. The rules that for metric, hopefully you remember most of the important ones. 1 kilometer, kilometers big, 1,000 meters, and so then 8.25 kilometers, we just multiply by that. Actually, in metric, this is one of the nice things, we just move the 0, don't we? So that's 8250, and hopefully you can do those 2 without the calculator. This next one's tough, though. I mean, it's 22 feet into meters, going from imperial to metric. There's conversion rules, but there's several ways we can do this, and this we took in previous grades, grade 10, grade 11, and it's kind of just a part of our life having to deal with these unit changes. So how do we do it? Well, one thing is we could look in our textbook. This is the last page of your textbook, and here are some of the things. So one way we could do it is to look up the right conversion factor, and this is what I'll do for the most part, but there's other ways too. You could use Google, right, or an app if you wanted to. So let me see if I got my Google handy here. Let's see, this is Google. So I forget what the fact was. It was we wanted to know what 22 feet was in meters. So in Google, 22 feet, just type in 22 feet in meters, and amazing, it'll pop right up, 6.7 and change feet. So let's just write that in there, 6.70 meters. Get back to our note. And that's approximate. We'll show you the textbook type of way, but it's kind of, in real life, what are you really going to do? You're going to maybe use Google, or you have an app for your iPhone. You might just look on a tape measure, right? So look, where's 22 feet? Obviously this isn't 22 feet. This is 4 feet, but 4 feet, it looks like, is, what does that say, 22 centimeters, right? So you can just use a tape measure. So now let's get back to sort of the textbook way to do it. In the textbook way, we got to find the right fact. And if we're going from feet to, what are we going from feet to meters? We already have the right answer, so we'll be able to check it. Feet to meters, we just got to find the right fact. Feet to meters, there it is right there. So 1 foot is 0.3048 meters. 1 foot is 0.3048 meters. And so if I wanted 22 feet, how do I get that? Well, to get from 1 to 22, I multiply by 22. So I'm going to go 0.3048 times 22, and I'm going to get my answer. And my answer is exactly what Google gave us, of course. And there's the exact number, and we'll write the rounded number in there. Last one number one. 4.6 meters to inches. Let's look up the right rule. Meters to inches, meters to inches. So metric to imperial, meters to inches. There it is right there. Don't write in your textbook. 1 meter is 39.47 inches. 1 meter is 39.47 inches. And so then if I wanted 4.6 meters, I'd go that number times 4.6. And I'm going to get a big number here. Decimal 562. Round off to maybe 0.56 inches. Now, this is weird seeing decimals of inches. Usually, we'd round off to, we use fractions for inches, right? So there we go. Conversions. And we'll be practicing that this entire unit. So be patient with yourself. Be patient with the textbook when it asks you stuff in different units. Notice our units are all good here. We want to calculate x. Well, triangle and 3 sides. It's a right angle. Right angle, remember, points at the hypotenuse. And the other 2 sides, this is Pythagorean theorem, right? H squared equals a squared plus b squared. That's a little bit messy, but I think we can handle it. The hypotenuse goes on one side by itself. The other 2 sides are the 2 legs of the triangle, and I can write 17 squared equals, well, x squared plus 8 squared. I'm running out of room here. Then we plunk 17 squared into our calculator. That's 289. 8 squared, 64. I'm subtracting 64 from both sides now. On the right side, I'm just left with x squared. On the left side, I got 225. Got to take the square root of both sides. And that's 15. And notice that makes sense. The hypotenuse is the longest side. 15, that looks okay. Finally, in this triangle, this is what we were doing yesterday, some trig review. Remember SOHCAHTOA. So the sine of A, and there's our angle A. We have to identify which is the opposite, which is the adjacent, which is the hypotenuse. Remember, 90 degree always points at the hypotenuse, so that one's the hypotenuse. And from angle A, we want the sine is the opposite. This is the opposite side, isn't it? So sine is opposite over hypotenuse, 23 over 29. For tangent, tangent is opposite over adjacent, opposite over adjacent. Adjacent means next to, remember? So from angle A, we want angle A opposite over adjacent, 23 over 17. Cos of B. Now we got to be careful here. Different letter means, if I do angle B here, from angle B, this is still the hypotenuse, but these change spots, right? From angle B, this is the adjacent side, and that's the one we want for the cosine. Adjacent over hypotenuse is the cosine. Adjacent over hypotenuse, 23 over 29. Okay, that's the end of the 3-minute review. A lot more than a 3-minute review, but hopefully you got some of the rust off, and we're ready to go for the first lesson of the day. And it's 1.1, finding sides and angles, pages 2 to 6, and a couple of different expectations to review the Pythagorean theorem, which we already did a little bit, measurement unit conversions, which we already did a little bit, and we want to find unknown sides and angles in right angle triangles using trigonometry. So this is all going to be right angle triangles. Here's an example. Ferd is building a deck as shown. How long should the missing side be so that the deck is rectangular? give your answer as a metric answer and imperial answer. So this is something that we're going to face the whole unit, is this idea of, you know, sometimes it's in imperial and sometimes it's in metric, and we've got to be good at both. Notice this is particularly silly because the diagonal of the deck is in meters, and the one side, you know, the length of the deck, I guess we could call it, is in imperial, right? So it's a bit silly, but that's okay. These things happen in math class, don't they? We have to change them both to the same unit so we can use, it's going to be, I think we're going to use Pythagorean theorem, right? We want to know how much this side is worth so that it's square. So, well, not square, rectangular, so that this is a right angle triangle. Good. Well, I'm going to change it to centimeters. So this side here is 480 centimeters. This I'm going to change to inches first and then to centimeters. So to inches first, 10 feet is 120 inches, right? Because 1 foot is 12. Multiply by 10, multiply by 10. We're all good. So then 10 feet, 120 inches. So plus the extra 8, that's 128 inches. But let's change that to centimeters. We look up in our chart at the back of the book, and we get the fact 1 inch is 2.54 centimeters. You can check that out, or you can use your Google app, I suppose. On a test, I'd probably expect you to use these facts. We want 128 inches, so I'm going to take that and multiply by 128, which is a big number, 325 and change. So that's 325 centimeters about. And now that I got them in the same units, I can actually use the Pythagorean theorem. Substitute in. Hypotenuse is the longest side. It goes by itself. X is the side that we want to find to make sure it's square. Clean this up. What is it? 325 squared. And these are big numbers. Jam them into a calculator. 230. You should be checking these as we go along because I make mistakes, and just because I make a mistake, I'm not going to stop the video and fix it and re-record it. You're going to have to just make the adjustments on your note, and tell me, make fun of me about where I made the mistake in the video the next day when you're doing homework. I do make tons of mistakes. And that number is 124,697. That's lots of centimeters. But then we got to take the square root of both sides. Square root of both sides is about 353. And that's approximate. So this step, what did I do? I took the square root of both sides. All right, so I'm going to say the deck side should be 353 centimeters. Well, that's not the units that we'd use even in metric, right? We'd change that to meters, probably, right? 100 centimeters in a meter. And I guess they wanted it back as an imperial answer too. So we've got to find either meters to inches or meters to feet or centimeters to feet. We need something. I'm going to just maybe do a little bit more work right here. The conversion factor that I found was 1 meter is 3.28 feet. And so then 3.53 meters is that times 3.53, which is 11.57. Now, notice 11.57 is a bad imperial number, right? Because usually it's fractions. So if we wanted just to be, rough here, we could say 0.57. Well, that's about a half a foot. 0.5 would be a half a foot exactly. Of course, if you were in Mr. Faber's class and you rounded that to 11 and a half feet without using inches and fractions of inches, he'd probably get angry at you, but that's going to be good for us for this question. I think this video is running long, so I'm going to stop there and we'll see you in part 2 in just a moment.